Okay, this is a Mil-Spec trigger group. This is a Mil-Spec style safety selector. Right now it's in the fire position. Now it's in the safe position. There's a notch here. So this is not a perfectly round drum, it's like a semicircle. And when the safety is in the fire position, there's enough room for the trigger tail to come up and release the hammer. The trigger tail is underneath this drum. But when the weapon is unsafe, because the way this spun, now the mirror image of this side is on the bottom side, and now there is a smaller space in between this drum and that trigger tail. So when I pull this trigger, it cannot move enough to release the hammer. That's what causes a Mil-Spec safety and trigger mechanism to be safe when in this position. Now, very important to note here, the diameter of this semicircle is actually a different diameter than the diameter here and the diameter here, where the safety selector is sitting in the bore or the hole on either side of your receiver. And this diameter dimension across this semicircle is going to be critical because the distance between the edge of this circle and this tail is dictating how much free space exists between these two parts. More on that as it relates to the Super Safety Selector from Atrius in a minute. Okay, now let's take a look at this Mil-Spec safety selector. You remember what it looked like when it was installed in the lower. We had one edge of the lower holding it here and another edge of the lower holding it here. We have this stepped down area here. When the trigger was in the safe position, it was oriented like this. When the trigger was in the fire position, it was oriented like this. I'm sorry, when the safety was in the safe position and when the safety was in the fire position. Now here is a Schmid Mil-Spec trigger. I bought, this is an ALG QMS quality Mil-Spec trigger. So these are Mil-Spec Schmid triggers that have polished sear surfaces. This is the trigger tail. And when the weapon's in the fire position, and you pull on the trigger, it pivots into this notch and drops the hammer. But when it's in the safe position, the notch is gone. So before it has a chance to release the hammer, it bumps into the semicircle, okay? And obviously, if this semicircle was this diameter instead of stepped down, then there would be less room for this trigger to travel. Let's take some measurements. Okay. Across the middle section, 0.3295, we're going to call that 330 thousandths of an inch. Across the section that sits in the lower, 372. So we have from 330 to 372, that's 42 thousandths of a difference between the two, right? Follow me so far? That would be 21 thousandths on the top and 21 thousandths on the bottom, because the difference between the diameters, 372 and 330, the difference between those, half the difference is on this side and half the difference is on this side. That'll be more important later. So remember those numbers, 330, 372. All right, I'm starting this video showing you the dimension of the cam of the Atrius lever. 372. 371.5, that's 372, okay? Well, 372, if you guys remember, was this dimension. This dimension that interacts with our trigger tail was 330. But this dimension on this Atrius lever also interacts with the trigger tail. So one thing I don't understand, and maybe Atrius can explain it, is why the dimension across this cam equals this dimension and not this dimension. Because all other parts being equal in the gun needs the area here or here that interacts with the trigger tail to be 330, not 372. Okay? My point is this. If this diameter here at 372 is too big, then what would that create as a condition inside the gun? It will create a binding condition, a potential binding condition. If this diameter matched what I would suspect to be the ideal diameter of 330, it would not have a binding condition. I'm going to install these parts and demonstrate the binding condition I'm referring to because of the diameter of this cam of 372 thousandths. Okay, here we have a partial installation. The Super Selector is installed, but there's no trigger pack installed. But what I want to show you is when we go from safe to fire to super safe, notice how this lever was relocated to the middle of the travel range. Let's see if I can lift on that. And now, due to our position in the middle of this space, this cam that we measured earlier at 372 is what is going to interact with the trigger tail, because it is now taking up the same exact space as our Mil-Spec selector used to take up, particularly this stepped down portion that measured 330 thousandths. Now, taking up the same space, we have a round diameter that's 372 thousandths. Does that matter? Well, potentially yes, in my opinion. And I'm going to show you why as I continue this installation. I've taken this installation one step further. I've installed the trigger and disconnector, but there's no hammer yet. But I want to show you some more of the inner workings here. This gun is in the safe position. When I pull this trigger, the trigger tail, this right leg of the trigger tail, is interacting with this part of the Super Selector. I don't believe that the left part of the trigger tail is making contact with the lever. So this part is not touching anything, but this part, when I pull the trigger, is touching the, I don't know if we call it a cam or what, maybe not a cam, but you know what I'm trying to say. It's touching this portion of the Super Selector assembly. Now watch, when I put it into fire, note that this lever is still positioned on the non-ejection port side of the rifle. And what's driving this lever to the non-ejection port side and forcing it against the wall here is this spring. Okay? Now, I'm not going to drop the hammer because there is no hammer, but because we've rotated this assembly and moved this part of the mechanism away from this leg, it now has enough room to travel and release the hammer if the hammer was there. Now watch what happens when we go to super safe. The geometry of this portion here forced our lever into the middle. The lever is now in the super safe position. And what's important to see now, let me get this out of the way. What's important to see now is that the cam that we measured earlier at 372, right there, is now interacting or is now in proximity to the trigger tail. And you can see when I crank on it, it's engaging the lever, right? So that distance right there is less than the distance we used to have when this was installed, because this is 330 and this diameter of this is 372. So we now have less room for this trigger to move in relation to this lever. All right, let's install the hammer and I'll show you that part. Okay, now everything is installed. We are in the safe position. Hammer's cocked. There's a tiny bit of trigger movement. Definitely not going to drop that hammer. So great. Fire position. Note that our lever is still on the left side of the rifle, the non-ejection port side. Can release the trigger. Okay, that's all working good. Boom. Now my cam is, or my lever, my cam are in the middle. And fire. This is gonna go back. That's gonna move backwards. The lever's gonna move backwards with the bolt carrier. And then boom. Obviously you don't wanna hammer your receiver, but hey, for science. So everything is working correctly. So what may be the issue? Well, you say, look, this lever moves freely in super safe. Cool. Yeah, that's great. But when the rifle is fully assembled and the bolt carrier is pressing down on the hammer, all of a sudden I'm binding. Why is that? Listen. When the hammer's loose, I don't have binding. But when the hammer's down, I'm binding. Well, the reason is when the rifle is assembled and the hammer is pushed down, the hammer is actually gently driving the trigger tail upwards. Well, we've already established that we have less than optimal space in between this cam and the trigger tail because the diameter of a Mil-Spec selector is less than the diameter of the cam. So the extra space we had, call it the wiggle room, has been eaten up. So when the hammer's down, now that cam is rubbing against that trigger tail. And that, to me, does not seem like it should be that way. I did not engineer this product. Maybe there's a logical reason that it's like that. I don't really understand, and I would love to have Atrius explain why in the hammer depressed condition this binding is occurring. Well, I know why it's occurring, but the question is, why is that cam 372 and not 330? That's what I want to know. Now, what can you do to remedy that? Well, we know the relationship that is causing the interference is the trigger tail and this selector. Basically, it's going, they're touching. Now, it's not, it's the cam. The cam on the lever is in lieu of, or in place of this surface. And they're too close together, they're touching. So in order to create space, you can remove some material here, which I had to do on this one. And if you would say, well, how much? Well, we've already discussed how much. It's this much. The difference between the 372 and then this surface. Now, it's not the difference between 372 and 330 because half of that difference is on this side of the circle, half of that distance is on this side. So half of 42 is 21 thousandths. So somewhere around 21 thousandths, which is like, I don't know, half a millimeter, something like that. It's not much. But if you don't want unnecessary binding and friction in your mechanism, which is this, then you have to either reduce the diameter of that cam, which is a pain in the ass because it's round, or you drop the height of the tail on both sides. You might only have to do it on one side, to be completely honest, because the more I think about that, I think it's only the that left side that comes into contact with the cam, but it's easy enough to just shave them both. Now, first of all, I find that a little annoying because it's no longer a drop-in solution. The whole joy of something like this is not having to cut your triggers like you do on a Hoffman. But the other issue is once you reduce this height, if you ever pair this trigger with a Mil-Spec selector that is the 330 thousandths diameter in this middle area, well, now you have more room for this to move. And even in the safe position, if this travels too far up, you can drop the hammer when it's unsafe. Obviously, that's bad. So once you modify a trigger tail, I would not recommend using it with anything other than a Atrius selector lever that is 372, more or less, thousandths of an inch. Well, I hope that all made sense. It took me a while to wrap my head around it. I want to thank Chris for all his videos and his time with me understanding the engineering and manufacturing complexity that's here. But, you know, am I wrong? Is there something I'm not understanding? Is there some reason that it's acceptable for the hammer to be down and for this to bind? Is there some reason the diameter of that cam had to be 372 and couldn't be 330? I'm just curious. I think this is one of the coolest products in the world. And I would outfit every rifle I have with one of these once they come out with the ambi, because I'm left-handed. But I don't want to have to modify all those triggers. So maybe there's something I don't understand. and I hope Atrius will respond to this video. I'm going to create an intro, but I'm going to reiterate what I'm going to say in the introduction. I don't mean any ill will to Atrius. They've treated me great. I ordered this selector and they shipped it on time. I've sent a couple customer service emails asking about ambi stuff. They've always answered. They've been awesome. I've read some of their comment responses and they're essentially saying, oh, this has to do with tolerance stacking. Well, I don't think that's the root cause of the issue. Obviously, tolerance stacking, meaning like where the location of certain holes are drilled or the size of certain parts within this entire assembly, that could make this matter a little better or a little worse. But I think there's a fundamental issue when you've replaced something that's 330 thousandths with 372 thousandths and everything else stays the same. Like, that can't be good. And so when this thing is cycling hundreds and hundreds of times, something's got to give at some point. And that's why I think people were breaking stuff. Now, this is sole and separate from the issue of levers binding in the pockets of uppers. Let me just make that clear. We're not talking about, where the hell is my camera? We're not talking about that area. This has nothing to do with what I'm talking about today. This is solely an issue of binding the cam of the lever against the trigger tail. Well, that went a lot longer than I thought. Thanks for listening to my TED Talk.